Okay, what I think you should have noticed is that the sum of the interior angles of a triangle is 180 degrees. That means in any kind of triangle, whether it have a right angle like this one, or have three acute angles like this one. And now we know what acute means, see? Three angles that are less than 90 degrees. Or if I believe I have a triangle that has an obtuse angle, there's an obtuse angle, all these three angles will always add up to 180 degrees. It doesn't matter what kind of triangle I have. Now, I could sit here and prove it to you all day long, though it would be hard to prove because I have to use every example. But I'm going to show you a simple way to prove it, to show you at least one example. I'm not going to do it all three, but I'm going to do it with this right triangle. Okay. I made two other ones. They're all the same. So they are congruent triangles. What congruent means is they are the same size. Every angle and every side is exactly the same. Okay? So, and it's hard to show you because they're stuck with magnets, but they are congruent triangles. Now here's what I did. I could rip off all the angles, but that gets messy. So what I did was I labeled all the angles, 1, 2, 3, on each triangle. So, and I'm going to just show you that, watch, if I put them up this way, the right angle, of course, they all match here. This angle, 2, is the same angle in all the triangles, so is 1. So I can prove to you that 1, 2, and the right angle add up to 180. And if I do that, think about what it means to be 180 degrees. It means you follow a straight line. So watch what I could do. I could take any one of these angles, let's say the right angle, I'll put it there. And now let me pick a different angle. That was the right angle. Let me pick angle 1. I'll set up angle 1, let's say right here. Now the only angle I have not used, let me set up a little straighter, you know how good I am at this, but a little straighter. Let me set up angle, the only angle I haven't used is angle 2. So that these are the three angles of any particular one of these triangles. And what you should notice, and of course these are on a slant, but what you should notice is this is a straight line because the three angles add up to 180, so it's got to form a straight line every single time. So I showed you that with this triangle. I could do the same thing with the angles that are acute, all acute. I can do the same thing with a triangle who has an angle that's obtuse. I can do it in any triangle that I have. And of course, you saw that by going to that link. So that's kind of a really cool link where you can play and notice that they'll always add up to 180 degrees. Okay, so let's take a look at this next fact. All right, let's take a look at the next three angles. So I want to take a look at the next three triangles, and I want you to go to your workbook and try to solve these. All right, let's take a look at these triangles. Remember that these three angles have to add up to 180. Well, that's pretty simple because this one's 60 and this one's 60. So we know that's already 120. So what we have to do is go 180 minus 120. We have another 60-degree angle. Okay, so angle C is 60 degrees. And we'll come back to this and talk a little bit more about this. Okay, let's take a look at this one. In this one, we have a right angle here, so we know that's 90. So we have 90 plus 45, which is 135. But we know this one has to be whatever it takes to make 180. And these are not called supplementary because they're three angles, not two. So be careful with that. And now we have 180 minus 135, which is 45 degrees. Oh, look at that. You're thinking that, oh, we're always going to get the same number. No, that's just a coinky-dink. Let's take a look at this one. Here we know this should come out obtuse if it's just a little bit drawn to scale. We have 33 degrees, we have 42 degrees, so 33 plus 42 is 75. 180 minus 75 is 105. So that's 105 degrees for this angle here. And that's all you need to do because they have to add up to 180 degrees. Let's see if we can take the information about a triangle and extend it a little bit. Let's say we have a rectangle. Okay? So you remember what a rectangle looks like. I don't want to take this whole thing off the board because I know what's coming here. But let's say we have a rectangle. We have a rectangle. I want to know what is true about the four angles of a rectangle. Think for a second about what we know about triangles and how we can extend that to a rectangle. And as soon as you think of an answer, think about it a little bit, and then click back to your video and we'll discuss it. All right, did you think you figured it out? Do you think you know the sum of the angles, the interior angles of a quadrilateral? Well, again, we know that a triangle, the sum of the interior angles of a triangle is 180 degrees. So what we could do is we could figure out, or notice, that I can take a rectangle and make two triangles out of it. So in any quadrilateral, the sum of the angles of a quadrilateral is, well, 180 degrees for this triangle, 180 degrees for this triangle, so it makes it 360 degrees. Now, you may think, that's not really cool, but okay. But I'll tell you why it's so cool. That means I can take any figure at all, any figure. And I'm going to tell you, I don't really know what this is going to be until I finish it, because I'm like a bad drawer. Okay, so here we go. Oh, that's terrible, but you get the drift. Okay, this has got 1, 2, 3, 4, 5, 6 sides, so that's called a hexagon. I could figure out the sum of the angles in any hexagon by just forming non-overlapping triangles. What? That means make sure that I make triangles from one vertex that do not, therefore they will not overlap. Here's what I mean. Okay, if I take this vertex, it's already connected to these two sides, but it's not connected here. It's not connected here, and it's not connected here. So that means I can make, and they don't overlap, so don't make one here, because now we have overlapping triangles. Oh my gosh. So we have 1, 2, 3, 4 triangles. So 4 times 180, which is 720 degrees. So I know in a hexagon, the interior angles add up to 720. I could do that with any polygon I want. It's so cool. What's cooler is this 4 comes from somewhere else, but that's not for this course, but it's fun. Okay, so here's what I care that you know. Okay, fact. The sum of the interior angles, and this is not in your workbook, so you're going to have to write this down. I know how you love to write things down. Interior angles of any, oh, that's not of, that's on. Of any quadrilateral, be it a square, a rhombus, a parallelogram, is 360 degrees. Why? Because I can form two triangles from it. Okay? Remember, one triangle is 180. Two triangles would be 180 plus 180, 360. Pretty cool, huh? Okay, so that's what we know about a quadrilateral. Oh, that's going to leave a mark. Anyway, let's take a look at the next question. Okay, these are the problems we've already done, but there were some questions I want to address first. So the first question I want to address is, how many obtuse angles can a triangle have? Well, remember what obtuse angle is. Obtuse angle is an angle that's more than 90, less than 180. Well, we definitely can have one, because here is 105 degrees, more than 90, less than 180. Can we have two? Well, let's think about that. The smallest obtuse angle we can have has to be more than 90, so it could be 90 point something. But if it's 90 point, even if it's 90 point something, well, that's already too big because we already have more than 180 degrees. So we cannot have more than one obtuse angle in a triangle. So the answer is no, we cannot. And the reason why is because the three angles have to add up to 180, and there will already be too many degrees with just those two angles. Okay. The next one is, how many right angles? Well, the same thing. There can only be one, because 90 plus 90 would be 180. What would happen to the third angle? So again, there can only be one obtuse angle. There can only be one right angle. And of course, the last question is, how many acute angles can a triangle have? Well, it's possible to have all three. So they could have three, they could have two, they could have, they can have two. They can't have one, because if they had one, that means you'd need two more of the other type, and we know we can't. So they could have three or two acute angles, okay? But obtuse is only one, and right is only one. So that takes care of that problem. Okay, let's give you some definitions, which is why I left this on the board. There's two ways to classify triangles. One is by their angles, which we're going to do first, because that's what we have right here. By their angles means we have to decide how many angles they have and what type they are. Well, if you have three acute angles, you then have an acute triangle. But for a triangle to be acute, it must have three acute angles, okay? This has a right angle, and all you need to be a right triangle is one right angle. Think about it, you can't have two anyway. So this is a right triangle. And then the third way is to label as obtuse triangle. Obtuse triangle, again, you need one, only one obtuse angle, and you have an obtuse triangle. So one is to label it by its angles, and its possibilities are acute, right, and obtuse. And the only way you can have a right triangle is one right angle, obtuse, one obtuse. Acute has to be all three acute. The second way you can name your triangles is by their sides, okay? And it depends on how many sides are equal. Now, I have to tell you, I don't know what you actually call these, but I call this a dinghy. Okay, so if I make one dinghy on each side, that means all the sides are equal in length. When all the sides are equal in length, that tells me I have an equilateral. Equi meaning equal, lateral meaning sides, all equal sides. So I have an equilateral triangle. So if we label it by its angles, it's acute, but if we label it by its sides, it's equilateral, because equilateral means all sides equal in length. This triangle, I already know has three equal sides. I'll tell you how, sorry, two equal sides. I'll tell you how I know that in a minute. But I know this side equals this side, okay? That's called an isosceles, I-S-O-S-C-E-L-E-S. I believe that's right, isosceles. Sometimes I leave out an S, but I believe that's right. Isosceles triangle means two sides equal in length. And this one has no sides equal. Oh, by the way, if we wanted to, we could make this have like a double dinghy. That means that these two sides are equal, but this is not. I happen to know that this one has no sides equal in length, so I could give this like something like this, doesn't matter. But all the dinghies are different to tell me all the sides are not, none of the sides match in measure. Okay, and that's called a scalene triangle, when no sides are equal in length. Now, the reason I knew that there were two sides equal in length here and three sides equal in length here and no sides equal in length here was because of other facts that are in your workbook about triangles. The first one is opposite equal sides are equal angles, and vice versa. So because all these angles are equal, I know all the sides are equal. Here, because these two angles are equal, I know the sides opposite them are equal. So I know the side opposite this and the side opposite this are equal, okay? And in the last one, since no angles are equal, that means no sides can be equal. That just kind of falls out from the fact that opposite equal sides are equal angles. The next fact that I want to talk about is the fact that opposite the largest side is the largest angle. Well, since this is the largest angle, we know this is the largest side. But you already know that in a right triangle because that's called the hypotenuse, and we know the hypotenuse of a right triangle is the longest side of the right triangle. Here, I happen to know, and I did this on purpose. Notice I made this one dinghy, two dinghy, three dinghies, and that usually doesn't matter, but I did that on purpose just because for me, I know that this is the shortest side, so I only gave it one dinghy. How did I know that was the shortest side? Because it's opposite the smallest angle. This is the mediumest side, or the medium side, if we have that kind of name, if you want to name it that, call it that. And this is opposite the biggest angle, so this is the longest or largest side. I should say longest, not largest. Okay, but either way. Okay, so the longest side because it's opposite the right angle, the longest side because it's opposite the biggest angle. The smallest side opposite the shortest side. Okay, smallest angle opposite the shortest side. So those are the facts you need to understand about triangles. So you can label them by angles, by sides, and you can also pretty much tell which side's going to be the longest side by their angle or vice versa.